let's take a look at some various sampling techniques, which are methods that we can use to obtain a sample. Now, the first sampling technique that I want to talk about is called a convenience sample. This is obtaining a sample in which the individuals are easily obtained and is not based on randomness. Convenient samples are typically highly biased. Now remember, we want an unbiased sample. So the fact that convenient samples have a lot of bias typically do not make this a good sampling technique when we want good data to analyze. Sometimes the argument is that some data is better than no data at all, but at the end of the day, you want a good data set when you're starting to draw conclusions. So typically lousy data leads to lousy conclusions. Now, some examples of convenient samples would be self-selection, where the individual decides to be in the sample, such as phone-in polling or internet surveys. So the person is choosing to log in and give you their data. Another example of convenient samples is asking a passerby to be part of a survey. So let's say, for instance, I am interested in getting data about I don't know, Math 127 students. All right, I'm interested in finding out from them maybe what their past math class was. Okay. So my population would be all Math 127 students maybe enrolled at JJC this semester. So a convenient sample from that population may be that I just post an announcement in our online course, and I say, hey, I'm interested in finding out what math class that you were in prior to enrolling in this math course. And then, so first off, it's convenient for me just to talk to you guys because I have access to you. And then the second thing is that if I'm just like, hey, I'd like you to maybe tell me what math class that you're in, then you then choose to say, okay, well, maybe I'll give her my data, maybe I won't, and then you can log into the site and then complete the survey and then send me your data. So it's very convenient for me to find you and ask you questions. I'm just going to throw this thing out there, and then you then opt then to give me your data back. So convenient samples are typically not that great. So if we're going to do something other than a convenient sample, what options do we have available to us? All the other options for sampling that we're going to talk about will involve randomness in some way. So the first one we're going to talk about is actually called a random sample. This is obtaining a sample where each item in the population has an equally likely chance of being selected for the sample. So at this point in time, you can think about this as being maybe names in a hat, where each slip of paper being pulled out of the hat has the same chance of being pulled out as any other slip of paper. So in my example of maybe getting data from Math 127 students, the thing is I would have to go to maybe down to registration, and I would have to get a list of all students who are enrolled in Math 127 this semester. Once I have that list, I would then use either a software program or a calculator that has a random number generator built in, and I can generate random numbers of students on that list that I then would have to call or email or send a letter out to and be like, hey, you've been randomly selected to participate in this study. Okay, so that would be what a random sample would look like. The next type of sample that we could obtain is called a stratified sample. A stratified sample involves obtaining a sample by separating the population into non-overlapping groups or categories that are called strata. Now, as an FYI, each stratum may be then further divided into substrata, so you can keep breaking this group down into smaller and smaller units, and then a random sample is taken from each of the strata. Right? So this is where the randomness is introduced. So the idea is you take your population and you're going to break it into these groups initially. So this is something that you as the statistician would do to your population. Then once you have your population broken up, then you would use this random number generator to say, okay, well inside each of these groups, we're going to pull a random sample from the groups. So maybe it was, again, I want to talk to Math 127 students. So maybe I decide to break my population up into males and females, right? So I want to initially then, so those would be two non-overlapping groups. So I would have in that point two strata. So then I would break my population up into males and females. Then once I have that broken up, then inside the male group, I would do a random sample. And then inside the female group, I would do a random sample. And then I would pool all those people together, and that would be my my overall sample. Perhaps I decide to break my population up into their status in school, so whether or not they're a freshman, sophomore, junior, senior. So maybe I break up all Math 127 students based upon that category, and then after I do that break, then I would then do a simple random sample inside each group. Maybe I break my population up into what their GPA is. So maybe I do from 4.0 to 3.1, and then 3.0 down to 2.1, etc. So then maybe I break my population up into GPA, then inside each GPA group, I then would go and do a random sample. And we, like I said, we could even do this into further and further breaks. So maybe I break it up into men and women, and then once I do that, then each of those groups is then further broken up into GPA. The idea is however far down you're going to break your population up into these groups, you do a simple random sample inside each of those strata. So then what you have is a little mixture of people from every different type of break that you have, so everybody is represented in your overall sample. Now the next type of sampling technique we're going to look at is called a cluster sample. So a cluster sample involves obtaining a sample by selecting all the individuals within a randomly selected group of individuals. So you do have randomness still involved here, but the key thing is you want to pull all the individuals. So stratified sample and cluster sample, there's some similarities between the two of these, but there's also some key differences. All right, so here's what a cluster sample would look like. So first off, your population is going to get grouped together. Now, you would normally want your groups to still be heterogeneous in some way. So you would still want them to be kind of mixed up, where all of the different kind of characteristics that were occurring in your population would still occur maybe inside each cluster. So let's say you were to cluster the students again, maybe by GPA. Okay, so you were to do the GPA from 4.0 down to 3.1, then you were to do the GPA from 3.0 down to 2.1, from the GPA from 2.0 down to 1.1, and then 1.0 down to 0. So maybe you still break your population up into that. Okay, so at this point in time I would have 4 clusters. The difference between stratified sample and cluster sample is out of these 4 clusters, I would use a software program then to tell me, I would randomly select a cluster. So like, let's say for instance, the computer says we randomly select cluster maybe 2 and cluster 3. Once a cluster is selected, in a cluster sample, you would get data from all the individuals in that cluster. The difference in a stratified sample is that in a stratified sample, once you broke your population up, inside each of these groupings, which we call strata, you would do a random sample inside each of these groups. So that's the major difference between a stratified sample and a cluster sample. Maybe let's give a different example. So again, still looking at Math 127 students, maybe I break my population up into section number. Okay, so I would get a listing of all the different section numbers inside for Math 127 this semester. once I have those groups, if I was going to then do a stratified sample, inside each one of those sections, I would use a computer to randomly select maybe about 2 students inside each section, and then I would email or call those students then to go get their data. If I was going to do a cluster sample, once my population is broken up by section numbers, the section would be the cluster, I would then use a computer to randomly select maybe 2 or 3 clusters, and then I would get data from all the students inside that cluster. So I have this graphic down here. Now this may be a little bit small for you to see, so I have it replicated also right here, so maybe it's a little bit larger and we can kind of see what's going on. So far out of the sampling techniques that we've talked about random sampling, stratified sampling, and cluster sampling. So far for random sampling, inside of your entire population, you would use a computer to randomly select a couple of people that you want to pull data from. Okay, so this is then looking at your everybody, you're going to pull out just some people. Stratified sampling and cluster sampling both involve taking your population and then grouping them in some way, shape, or form. Okay, so in this example, they've broken up your population into 2 strata. Down here in this example, for my population, I've broken it up into, it looks like 6 clusters. The difference is what happens at that point. Now, randomness is now going to be involved. So you, as the statistician, has forced the break in your population. So this is the human kind of part of this process. Now here's where we allow randomness in to generate our actual sample. Now in stratified sampling, inside each of those strata, you would use a computer to randomly select people inside each group. So in this example, it looks like they selected 2 people out of this strata and 2 people out of this strata. So there's where the randomness is introduced. In the cluster sample, once your population is broken up into clusters, you would use a computer to select the cluster. Once a cluster is selected, you then would get data from every individual in that cluster. So that's the key difference of the sampling techniques we've talked about so far. Now, the last type of sample that we could get is called a systematic sample. Now, in a systematic sample, you're going to obtain your sample by randomly selecting a starting point and then selecting every nth individual from the population. So here's where the randomness is introduced, is where you're going to start picking people. And then this would be then maybe you would select every 5th individual after that. Okay, so in this this graphic, so then you would say, okay, I'm going to line up my population. So in this example, I've got, it looks like 11 people in my population. You would use a computer to say, okay, between 1 and 11, randomly pick a starting point. So it looks like in this example, maybe the computer randomly selected, I don't know, the number 8. Okay, so then let's say I would just start right here. Okay, so this is where, and in a statistics course, you would talk a little bit more about the size of the leap to get to the next person. So, but in this basic example, we're going to say, okay, we're going to select every 3rd person after that. So then I would, individual number 8 would make it into my sample, and then I would go 1, 2, 3, and then individual number 11 would make it into my sample. And then we could then swing around back to the beginning, or we could say then from number 8, then I go maybe backwards 3 as well. So then 1, 2, 3, that person makes it in, and then 1, 2, 3, that person makes it in, until I have enough people in my sample. So in this example, you know, maybe I only want a sample of 4 people, so then once I find my 4, I'm done. If I had wanted my sample to maybe have 20 people, I would still keep going through my population, grabbing every 3rd person until I had 20 people in my population, but obviously, or in my sample rather. But obviously then my population would have to be much bigger than 11 people, because the idea is a sample should be a subset of the population. And as an FYI, if your population is not too large or unwieldy, and it is possible for you to get data from your population then that's what you want to do. If it is even feasible at all to go talk to your everybody, then you go talk to your everybody. And your population doesn't need to be huge. It doesn't need to be, thousands or millions of people. It's possible that maybe this Math 127 course this semester, so this online section, you guys are my population. You guys are my everybody, and maybe out of my everybody, I want to find out, what the test grades were on like the first module test. Okay, so that could be, in theory, my population, and I could go out and I could get that data. By the way, collecting data from an entire population, that is called a census. So the idea is if your population, if it is even feasible for you to go talk to them, you go talk to your population. However, if it's not feasible, then you talk to a subset of your population called a sample. And your sample is usually significantly smaller than your population, just because at that point in time your population was too large and unwieldy for you to go talk to, so you're just going to talk to this subset. So there are other sampling techniques out there, but these are going to be the main ones that we are going to talk about in this course. So we have convenience sample, which is actually not a very great sampling technique, but it's used a lot, unfortunately, in our daily lives for people, how they get their data. So you want to be aware if someone is doing a convenience sample, just so that way you can be a little bit more critical of the results that they're reporting. And then there are these 4 techniques that all involve some sort of randomness. So there is just what's called a random sample, a stratified sample, a cluster sample, and then a systematic sample.